Dr. Zahn, can I ask you something before we get started?
No.
Okay. Never mind.
Yeah.
So I missed Tuesday.
Okay.
But I went through yours, like the video,
Mm-hmm.
and before you did the 4-year stuff, and you were trying to get that first line. Let me see if I can find it real quick. So I did this thing where I did like head 1 of creatures / asterisk dat, and that almost worked, but it gave me the like equal signs with like the +than symbols, and then gave me like creatures basilisk dot dat, and then gave me them. Does that make sense?
Maybe.
Like it almost gave me it.
Okay, so let me get to where I need to be. Maybe you can just share your screen. I'll take a look at what you're talking about.
Can you see it?
Okay, for I and star.dat, do head 2 I tail 1 done.
Oh, the one above it. This head -1 right here. I don't know if you can see my cursor.
Oh, okay. Head -1 creatures. Star.dat. It worked.
So is this fine if it also gave this?
Yeah, I mean, you just have to be, that's kind of that's what the head likes to do if you give it more than one file.
Okay.
It's just letting you know which file each one came from.
Oh, okay.
Does that make sense?
Yeah.
Yeah, so that worked.
Okay.
Mm-hmm.
All right. I did it the other way.
When you do it the other way, with the for loop, hit the up key a couple times. Let's see.
Right.
Or
like for my commands, I did a lot of stuff after that.
Oh, okay. But yeah, if you scroll back up to where you were, that for loop that you ran that didn't work. Yeah, right there. For I and star.dat, do head, and it said no such file or directory. You'd have to just give it the creatures directory in front of star.dat again.
Okay.
That's why it didn't work.
Yeah, because I think I ended up, I had to move into it. I had to do that.
You were just in the wrong spot at that point.
Right.
Okay. Yep.
Cool.
So, looks good. Well, people are starting to roll in. We'll go ahead and get to work. So, assignment 2 is kind of what we're working on right now. And we've just got 6 tasks. Most of them are pretty simple. And then the 6th one, well, 5th and 6th one kind of aren't that simple. Right. So I'm going to hopefully give you the tools today to be able to do those 2 as well.
It looks like the redirect in question 1 is already in the assignments 2 section.
It is?
There's already an mlines.txt in there.
Oh, is there?
Yeah. It doesn't look like the way ours did. Where we were basically operating within these files, these directories.
Right.
But this one shows the long address of all of the names.
Gotcha. What probably happened there is that I did it as an example last semester and accidentally pushed it to GitHub. So you can ignore the mlines.txt. for these purposes. Okay. So let me share my screen. And kind of show you how every other assignment is going to work from now on. I'm in data course, my last name. Okay. I'm going to go to assignments, assignment 2. Okay. So I'm in my assignment 2. You should have your own assignment 2 directory within a directory called assignments within a directory data course Hartung, right? So let's see here. I look around and yeah, okay, it's already in there. So that was my mistake. Sorry about that. But this is actually the output that I'm looking for. Now, here's the thing. Your assignment 2, the code should be carried out from within assignment 2 directory. And so in order to look at the files that start with M, you really are going to have to go back and then forward into data, data shell, data, PDB. Does that make sense?
Yeah.
Let me know if it doesn't make. Okay, so yeah, your code should work from assignment 2 in your data course. And all of us are going to have this file path in our data course, your last name, because we all have data and assignments right there in the main folder. Okay, so yeah, that actually looks correct. Okay. So let's play around with this. I'm looking around. I don't have my data, but I want to look at my data. I can list the files that are back 1, which is the assignments directory, back another, which is the main data course, my last name, and then forward into data. And I can start hitting tab to autocomplete so I don't make spelling mistakes. Okay. Use that autocomplete. Data, data shell, data, PDB. So from where I am in assignment 2, I can list all the files and directories way back there in PDB. Okay. This is a relative file path. Again, if you're tired of me saying this, it's because I'm tired of people's first exams not properly using relative file paths, so nothing works. Okay, I really want to hit this home. Let me know if this has anything that's not clear about it. That little command right there, why that worked. We good? We golden on this? That file path makes sense to you? All right. So using our wildcard that we learned, our little star, the asterisk, how do I list all the files there that start with ETH? So I want ethane, ethanol, and ethyl cyclohexane.
WC space dash L ETH star.
Oh, I just want to list them. I don't need their line counts or anything right now.
Okay.
Once you've got it, throw it up in the chat. seems like y'all might be struggling a little bit. All right, Eli, I'm going to copy yours in, paste it here, and run it to see the error.
Oh, I'm there. I'm not where you guys are. Whoops.
You need to be in assignment 2. Okay, Steven. Well, that didn't quite work. You did 2 things here. The first thing you did was list everything in the PDB. So we're on the right track there. And then you asked it to list this file, and that file. And it
Could
said,
that
can't find them.
Could that be where I do the like ETH star?
Yes. So I'm gonna hit up. I'm just gonna backspace through all your stuff. ETH star. That worked. All right, why did that work?
We told it where to go and what to search for.
Yeah, we told the ls, the list command, exactly where to go and what to search for. Things that start with ETH and then end with anything. Okay. So that worked perfectly. So where I need you to be in terms of your understanding at this point is, if this makes sense, you're doing good. You're like on the right path and we're ready to move on. If this doesn't make sense, please let me know so we can go over it some more.
What is that, the ... /... mean?
Go back one, go back another. So
Okay. ...
means parent directory, the previous one. So since we are in data course through last name, assignment, assignment 2, if we want to get to our data, we first have to get out of assignment 2 and assignments, go back into my last name, and then forward into data. And so ... means go back 1. And so we're in assignment 2, we go back 1. So we're in assignments. All right, that was this part. And then we go back another. So now we're in data course my last name. And only then can we go forward into data, data shell, data, PDB.
That makes
help?
sense.
Yeah. So yeah, we're just kind of like telling it we got to back out of assignment 2 directory, and then we can go forward off this other branch into our data. Okay. How about anything that starts with a P and ends in an E? So I want pentane, piperine, propane, but not pyridoxal. Starts with a P, ends with an E. And just these PDB files. All right, Stephen.
I don't know if that'll work or we'll have to use a pipe.
It's not going to work. We'll see why. No such file or directory. You're so close. All right, Eli's got the answer here. What's the difference?
You need to have the file ending.
It's not that the file ending is actually important. It's that that's the file. It's part of the file name. So propane. You said, show me all files that begin with a P, have anything in between, and then end with an E. That's all well and good, but we don't have any files there that match that pattern. Okay. We do have propane that ends in .pdb though. Okay, so we do need to give it that extension. Okay. I'm going to try something crazy. ls backback data shell data pdb p star e star b. Why did that work? We got the same result.
It's asking the same thing. It needs to end in a B, which the first one did not.
Exactly. So I just did it this way also to show you that really the file extension itself isn't important. It's the letters that are there or whatever, the characters. So it ends in B. It starts with a P. It's got an E in it somewhere, and then it ends in B.
That gave me massive errors.
This did?
Yes.
What kind of errors?
Never mind, I figured out. I forgot the ls.
Ah. Yep. Okay. This is definitely a safer way to search for it, because we could have any file, maybe it didn't end in an E, but it just had an E in it. So this is searching for, starts with a P, somewhere has an E, and then ends with a B. But I want you thinking about kind of how these wildcards work, and that'll get you through this assignment. Okay, so we've done this first one. File names begin with M. Well, that one's pretty simple. M star .pdb. So we got maltose, menthol, methane, morphine, mustard. Okay. Number 2, redirect the output to a new file. Oh, you know what I forgot? I didn't just ask you to list them. I wanted you to count the lines. So how do I do that?
WC -L.
Yeah. Okay, so there's the number of lines in each of those files. Okay. Now redirect it. Instead of spitting out the output to the screen, how do we get that into a file where it's maybe more useful for later, for a collaborator to read into data analysis?
You're saying last time it was the greater than arrow?
Yeah. And then where are we putting this file?
Says M lines text dot text.
And are we sure that we want it here? Or do we need to send it somewhere else? What's the instruction say? Yeah, we want it in assignment 2. And that's where we are, so we can just leave it exactly like this.
So will that write over the one that's already in there?
Yep, it will. And again, I'm sorry about that. It got left over accidentally. So we can look at that, mlines.text. There's our output. How about for number 3? For the file animals.txt in data shell data, get an alphabetical list of the unique animal types that were observed and redirect that to a new file called animals.txt. Alphabetical list of the unique animal types that were observed. All right, let's take a look at this file. So I'm going to cat. And where was it? It's in data shell data. Animals.txt. All right, remember this old gem? We played with this one before. We chopped it up and cut it. So who remembers? No, it's been a week.
Use the delimiter.
Okay. In what command though? What program are we going to use? You're right. We can separate it based on the comma.
Are we looking at cut?
Cut.
Yeah.
Yeah. Cut. Now cut. If you look at the help file, it wants a delimiter and it wants some fields. Okay. So let's see here. Cut. Our delimiter is what?
Comma.
Yeah. So we're gonna say, hey, cut everything based on comma. And then what's our field?
2.
2. And then now we just have to tell it what file. Data. Don't forget to use tab complete. It will save you. So we've cut this file based on the comma and taken the second field, which is our animals. Okay, we want an alphabetical list of the unique animals. How do I do that? We've got we've got sort and unique are 2 programs that we can pipe this to. And so don't forget our pipe. I'm just going to hit the up key to go back to what I've got. Okay, so our output looks good. We're on our way. I'm going to pipe this to sort. Just like that. Okay, that's alphabetized. But it's got rabbit 3 times and deer twice, and I just want the unique list. I don't want the duplicates. So I'm going to hit up again. And it says, okay. I'm going to pipe that again. We can just keep piping all we want to unique. And there's our alphabetized list. All right, so for number 3, all you need to do is redirect that to a file called uniqueanimals.txt there in your assignment 2. Okay, let's move on to number 4. in the directory data, there's a file named biologplateData.csv. We want a command that gives a list of the unique carbon substrates the plate measured and save it. So it's basically just like the animals thing we just did. And we're going to make a file called unique csubstrates.txt. So I'm going to give you a chance to work on this for a minute. See if you can recreate what we just did, but with a new file. So I'm going to do head just to take a quick look at it. Data biologplateData.csv. This is a glimpse of what this file looks like. Okay, so these biolog plates are 96 well plates. They measure absorbance based on whether or not the microbial community is eating a certain carbon substrate. Okay. Every little well in the plate has its own special carbon. If the bacteria can eat it, it starts turning purple. So we've got our header here. Sample ID, replicate, well, dilution, and substrate. That's what I want. I want the substrates. A unique list of those.
Since
Okay.
there's many commas, how do we differentiate the delimiter?
Well, I'm gonna let you figure that out. I think 5 minutes should be plenty of time for you to kind of play around, since we've already got our formula, basically. We're cutting, then we're piping to sort, and then piping to unique. I think you can get it. I want you to get it yourself. So put it up in our chat if you think you've got something. Or just talk to me. I don't care. Either way.
Well, you just need to do field 5, right? Wait, or did you not want me to say that?
1, 2, 3, 4, 5. Let's see. Something like that. I think you're on the right track.
Can we add the previous letter to before the comma so it specifically finds that delimiter?
Previous letter. What do you mean?
Like in dilution, there's like add the N and the comma or the 001s.
Well, I'm not really concerned about this is the dilution here, the dilution factor. We don't want that at all. I just want an alphabetized unique list of these substrates. I'm going to put Shannon's in. So we are going to cut based on the comma as a delimiter. We're going to take field number 5. And the file we're going to do that to is back, biologplateData.csv. Then we're going to sort it. Then we're going to get the unique values. Looks pretty good to me. Now there's one little thing I don't like, and that's the header is still in there. I'll let it go this time. Since this isn't really a command line class, we don't need to worry too much about it. That's all right. The header's in there, I'll accept it. But yeah, so that's the command right there, and of course you do need to send that output to a file called unique c substrates.txt. Okay, let's look at another one. This one used in our wildcard again. In data shell data, a command that finds the longest txt file. So let's list them. Those are the ones we're looking for. The longest in terms of number of lines. How would I find which of those is the longest?
Could you word count line all of them?
Why not? The world is your oyster, and the computer terminal is waiting for your every beck and call.
Would it be WC-L?
WC-L.
And then the ls data, the whole thing above.
Then I didn't catch that. ls data.
What you just typed in. You just click the up arrow and it'll autofill it. Then start with WC-L, so where the word count and the length, the word count, and then it will sort it.
Paste it in. I'm not sure I'm getting what you're saying.
Maybe not the ls, because you don't want it to print it. Maybe just the...
Okay, so this isn't gonna be pretty. You asked it to count the number of lines in a file called ls accidentally. So if we go back there and take out that ls, now we're starting to be on the right track. So give me the number of lines in these files, and you didn't hit tab to autocomplete because there is a mistake. Who can find it?
We're missing a forward slash before data.
Yeah. Right there. Okay, so now we're going back. There it is. So that does work. And we've got our number of lines for each of those files. So now we want the longest file. Which one of these is biggest?
Sunspot.
Well, sure, but how do we output Sunspot? I mean, if this consisted of thousands of files, you wouldn't be able to easily glance at it and see which one was longest. So I see Eli, you've done basically this, and then you've sent it to sort, right? Which would kind of be an interesting way of doing things. And then you said head 7, and then tail 1, and that doesn't work for me.
Why didn't your sort put the biggest one at the bottom?
Why did yours?
I don't. Well, when I did sort, it like went in numerical order.
Hmm.
Is your sort going off first digit? Oh, it is.
In fact, most of us are probably going to have this, where sort has to be given a little flag to say compare according to numerical value. So I have to say sort numerically.
Okay.
Yep. So let's try that. If I give it the N flag, sort numerically, and then you said head 7, and then tail 1, and that didn't work.
So I just have a question going back to the sort. So
Yeah.
mine did just do the numbers also without the negative n or minus n, and I'm just
Okay.
wondering, like, how would I know that it went like for yours it didn't work, but for me it worked. So how should I know that, like, oh, maybe I'm doing this wrong, or should I just always be aware that I should check or something?
Yeah. So this is actually a pretty valuable lesson, is that we're always, every new command that we learn, especially like once we get to R, we're going to open up RStudio today, but always read the help file. Absolutely. And so
Okay.
this is probably just like a weird, we have different versions of Bash going on. Are you on a Mac?
It's a Windows.
Windows, okay. So it's probably just a different Bash version. It's okay. I wouldn't lose any sleep over it right now, except go ahead and just take the lesson of always read through the help documents of new commands to kind of see what's going on.
Alrighty, good to know.
Yeah. Okay, so I'm going to give it the N so we're on the same page. So they're the biggest ones on the bottom. Eli, why didn't your head 7, tail 1 work?
It should be head 6.
I actually, while I was practicing, made a file and put it here, and that's why mine is 7 and not 6.
Ah. All right. Yeah, so head 7, tail 1 was giving this, which was the last line. So you could just say tail 1 also to get that. So head 6, tail 1. There we go. I know that it's not interesting that sunspot.txt has 3080 lines, and that's the most of any of the txt files. What should be interesting, though, is this concept of piping together a few different commands to kind of get what you want. And the way that we do it kind of iteratively, right? We get the first thing to work the way we want. We say, okay, here's one section. let's add something to that. What if I did tail 6? Okay, all right. Or that's not working. Head 6. There we go. So now we're starting to isolate that biggest one. So tail 1, and then we get it. This kind of iterative process of chaining together short little commands, seeing where they take us, and then kind of building on them is going to be absolutely fundamental for data analysis. Like when we're making graphs, this comes in real handy. Like run our graph, chain in this little thing. Okay, now we're chaining in another. So that's what I'm hoping you're taking from this, more so than becoming a command line expert, is how the file paths work and how we chain things together.
So sort worked on ours without the -n, and we did it, and then you ran it to see if we did the assignment right, and it's not working on yours because you had to do the -n. Would that get us losing some grade?
I might have accidentally taken points off, and then you would just say, hey, it worked for me. Like, okay, fine. I'm also looking for that file, right? So if that's the easiest way for me to grade these early things is I look at unique C substrates.txt. And if your file's right, it's right. After this class period, today's Thursday, right? Yeah. We're pretty much moving away from this terminal thing, and we're all going to be on the same page using R, so it won't be an issue. Okay, so that was number 5, and then number 6.
Are we putting that anywhere?
No, that one didn't even go anywhere. It's just the command. Number 6, we've got this data shell many files. There's a bunch of subdirectories, and there's some text files that contain a list of numbers. So let's take a look at this. I'll open it with data course, my last name, just so we can take a look. Data shell, many files. All right. This is obnoxious. In each of these folders, buried within a subdirectory, is a text file full of numbers. Well, that's annoying. So in that case, let's ls data shell many files, lowercase, many files. I list them and I just get a bunch of directories. So they're kind of buried into these weird subdirectories. Each file gets its own folder. This is super annoying. It's also exactly how sequence data comes back from like a multiplex Illumina machine for DNA sequencing. Comes back in this form. Okay, so if you got 300 samples you were trying to sequence, each one is going to be buried within about 7 layers of little file folders and everything. How long would it take you to click through each one of those, find the file, copy and paste it somewhere? It's really obnoxious. Okay, so we've got another command, and this will basically be our final command that we learn in the terminal. It's find. And find is kind of a special command. It wants a few arguments. The first thing it wants is where to start looking. And so I'm going to say, hey, find You give it a directory. You can hit enter at that point, and it's just returning the path to all of these files. I can also give it some other flags. I can give it type F or type D. Type F just returns the files versus directories. So I can find some files. I can also say name and give it a pattern, anything. star.txt, for instance. Or star 80 star.txt. It's just returning things that end in 80.txt. So this is just like your Finder on Windows or Mac where you're looking for files. It just works a whole lot faster and it's a bit more flexible. So we can find in our many files directory all the files that have the name that ends in star.txt. And then this is where find actually becomes really, really powerful. We can execute any command or series of commands we want on all of those files. So we don't even have to know where things are in our computer. We can say word count L, and then this is annoying, I understand. You have to give it this little series of commands here. What do you want to execute them on? The open close curly brackets means all the things you found. And then the backslash semicolon means I'm done with you, find. Go out and do your thing. So your basic structure, I'm going to type it into our chat here. Find, and then directory. Some pattern for the names if you want. And then you can execute your commands on open close curly brackets space backslash semicolon. Look, there's no need for you to memorize that. It's okay. You're really just going to be using it for this assignment. Unless you go on to actually do bioinformatics, then you're going to be using it every day. But that's the only reason I've got it memorized. For now, this is the form, and let's take a look at it. We're going to find every file that ends in star.txt within the many files directory, and we're going to count the number of lines in all of those files. Ta-da! Done. Well, they all have 300. Okay. I can go back up here and change the directory to just look for any file that ends in txt in the entire data course and do the same thing. So, what else might you want to know about files?
If you were working with DNA, could you search like a sequence and see which ones have it?
Yep. So I could find which files have the sequence 7 A's in a row. That was fast. So you can search your entire computer, an entire hard drive, for DNA sequences that contain any pattern that you want, and it does return it in a split second. So these are really, really powerful tools for bioinformatics. This class, you're not going to need to know how I did that. That's okay. We're going to be doing some of that in R as well. R is a lot slower for this kind of data processing, and so a lot of bioinformatics will just use the shell here. So, yes, to answer your question. So, shameless self-promotion, I've got a bioinformatics class that I'm teaching right now, teaching you exactly how to do that. So yeah, it'll be offered for now every spring.
So for that question, we're gonna, for the name search, we're gonna put that some lines in search.
Yeah. So we're gonna, instead of executing word count L, we're gonna execute that sumlines.sh. So I wrote a little stupid bash script. Okay. It goes in there and calculates the sum total of all these numbers in each of those files. It's in data shell scripts. So keep in mind, I'm still in assignment 2 right now. All right, you shouldn't be leaving that assignment 2 directory. So let's take a look at it. I'm going to cat data shell scripts sumlines.sh. So let's look at the contents of this. It's real short and simple. It's going to go in there and basically just print out the sum total of all these little numbers in our, oh dear, wherever they were, the ones we found. Yeah, all these many files, right? It's going to go in, look at them, and calculate the sum. It's just something to do. Okay, so let's see how that's going to look. Instead of executing word count L on all of those, what would I do? If you want to run a bash script within bash, you have to say bash and then the path to the script. So I'm going to copy and paste this into our chat. I want you to replace the X's with something to make it work. That's sumlines.shell. We want to run that script on all the files. Who needs a hint?
I think I might have it.
Did you stick it in the chat? I don't see it.
Yeah, I just put it in.
Okay. Maybe it'll come up in a second. Who else? This is a lot. I'm sure I'm losing some of you somehow. So let me know.
So when we type in bash, that's supposed to do the command that's in that file?
You have to give it the name of that file also.
So since I'm in assignments 2, do I have to do the whole data shell to get to that file?
Yeah.
Okay.
Uh-huh. Good. I'm glad you caught that. That makes me happy. That means you're understanding how these paths are working. We're staying in this one location and we're finding things over here and then executing this script over there on them, but we have to tell our computer where these things are. So let's see. I see yours now, Eli. Type F name, start at T. Yeah, that should work. What he's replaced the X's with. You know what? I'm gonna make this a bit smaller so we can hopefully fit it on one line. Okay, let's walk through this. This is an ugly command, but it's composed of a bunch of simple little pieces. We're gonna find some stuff. This is where we're gonna start looking. Right here. We want it to be files, not directories. We only want to return files that match this name. They end in star.txt. And then of all those things that we found, we want to execute a command. And the command that we want to execute is a bash script found here. Then we're going to do that to all the files we found and in the command. All right. Hopefully the plain language version of that kind of makes sense when you look at it. It's okay if it's a bit hazy, but I just want you to know what's about to happen when I hit enter. That's a lot. Okay. That's the output we want, presumably. Even though this is a dumb program that we ran that just summed up the number, the sum total of all the numbers in a file, this could have been anything, and that's how you would run it on tens of thousands of files simultaneously. We've got the name of the file and the total in that file.
I don't know why the semicolon gave me an error. It says unexpected token.
Did you do the backslash semicolon?
Oh, you know what? Went pipe.
Oh, pipe, yep. I'm not even sure what error that would give. Let's see. Yeah, okay. Okay, so that should get you through assignment 2. We've got 15 minutes left. I would like, do we want to open RStudio or just save it for next week? Let's just save it. We've covered enough like brain cloud, mess with your mind, difficult things today. It's okay. We'll save RStudio. In R that we start next week, we're going to start real slow on that also. We're going to see some of these exact same paradigms, though. We're going to see for loops. We're going to see pipes. We're definitely going to be worrying about where things are located in our computer and having appropriate directions to them. But the language itself is a bit different. I think it's a bit easier, and it'll be a refreshing change of pace. And it's a language written by statisticians to do statistics and data analytics. So some of the stuff we can do with it, it's kind of just a different wheelhouse than what the Bash shell is. Bash is like hardcore bioinformatics, text processing, ultra fast, where R is like, let's do an ANOVA. Let's calculate the statistical power of this design that you've got. Let's make a pretty graph or see if these two groups are different. So they do different things, but I think you're going to like R a bit better because it comes with graphs. Yay, graphs, nice and easy. Okay, so something to look forward to. Once this assignment is done, the only time you're going to be using the Bash shell is to push your assignments to GitHub. So don't lose track of that. Git add, git commit, git push. But that should be easy for you now. You know how to get around in your shell terminal. You'd be good to go. All right. I guess I'll let you out a bit early. I'll stick around for a few minutes if you have questions for me, though. Assignment 2 is due when? Like Sunday night or something?
So I have a question about turning it in. Do we just type out these commands that we've gone through?
Yeah, just in a text file. And so upload your text file containing the numbered lines of code from the assignment.
Oh,
So if you go to the assignment 2, it'll tell you exactly what to turn in.
So we're not going to push it to the repository?
No, no need
Okay.
yet. Yep. So assignment 2 is just a plain text file that's like task 1, here's how I accomplished it. Task 2, here's how I accomplished it. And you're good to go. So just to kind of, I mean, I know we're doing it together, and that's fine. I'm sure you don't mind that we're kind of going through the assignment before we turn it in. There'll be less of that as we get going. I just want to like kind of ease ourselves into how this works.
So on assignment 2, when it talks about cloning the other Git repository or the other file in the very beginning of the assignment, did you want us to work out of that, or did you want us just to work out of?
If you haven't done this already, you're good.
Oh, okay.
That's just so you have the data. We've already kind of gone through that.
Oh, okay.
Yeah. Usually there's like a late add to this class about this point in the semester, and so I put that there for them.
Oh, okay. I also had another question.
Yeah.
I also had another question about for loops.
Okay.
And I guess with the first task. So, are you able to do a for loop for that task? Like
for the first task?
Yeah.
Oh yeah.
Like if I want to do like for I.
The word count for the M lines.
Yeah.
The M stuff.
Yeah.
Yes. So I would do for I in those files that start with lowercase m and in PDB.
Oh, okay.
Do word count L, the value of I, done. Yep.
Oh, I see. Yeah, I think I just didn't add the .pdb after the M, the M wildcard. Yeah. I just like did it as like M, and like not the
Yeah,
file.
you need that star. But yeah, that would be the way to do it. Obviously, that's like a lot more typing than
Yeah. Then just the other way. Yeah.
WCL. Yeah.
Okay.
But doing stuff like that that's kind of what helped me get an intuitive feel for how for loops were working, was just kind of trying them on stuff like that to see what the output is. And sometimes they'll surprise you and you'll realize that you didn't really understand what you put into your for loop. And so it's
Okay.
good to try things. Once we're in R, we'll be doing for loops again with this syntax, and this gives us a bit more like readability, I think, and we can, do multiple things in here. Print I 4 plus I, and so this for loop is going to do two things. That's crazy output. We're printing 1 plus I and 4 plus I. So we've got 2, then 5, then 3, then 6. So you can kind of start seeing how these for loops are working and what order they do things in.
All right. Okay.
It's easier in R, for sure.
Yeah. All right. Thank you.
Yeah. All right, well, I'll stop the recording and we can all peace out.
I have a question.
Yeah.
Sorry. I can't find the recorded lectures for some reason. Where can I find those?
Let me show you.
Okay.
It's kind of frustrating. So if you go to our Teams, in the live stream, it's in the replies. So you have to like click on replies, and there you'll find the recorded meetings. Like there they are.
Okay, thank you.
Yeah. Yeah, that's kind of an annoying feature. All right. Well, I'm out of here. I will see you next week.